In this video, we introduce data linker. Label change wheel shows label changes as an eroding river. Sample wheel displays samples as a combination of a scatter plot, a loading diagram, and a bar chart. Filtering panel helps focus on nodes and edges of interest. Action trail records the modification history. Information wheel shows the images of selected samples and their neighbors. The tour function helps experts quickly become familiar with the visual encodings and interactions. Analysis on the STL10 dataset. From the label change wheel, the expert finds most samples are labeled within 4 iterations except a small number. These samples have a high ratio of label changes in later iterations. He turns to the sample view and examines these samples. The selected samples are in 2 regions. Both of them are noticeably deficient of dominant label samples. A1 contains images of snakes, a class that has never been considered before. As there are no labeled data for this class, the expert labels 5 samples in this region. In A2, the selected samples are far from their labeled ones, and they have high uncertainty. The expert labels 3 more samples in this region. Upon update, most samples are labeled within 4 iterations, and label changes are largely reduced. The overall uncertainty is also reduced. Next, the expert checks the remaining samples in the information view. Some monkey images have wrong predictions. Zoom into this region. The expert finds there are 2 clusters of monkey images wrongly predicted as dogs or birds, due to the small number of edges from the monkey cluster to these clusters. To increase the number of edges, the expert selects the region around the boundary and increase K. Wrong predictions are largely reduced. However, a few still exist. The expert randomly selects a sample S1 and checks its propagation path. The label of S3 is wrongly propagated to S2 and to S1. S2 affects the labels of several other monkey images. S2 is deleted as it is a class not of interest. The same operation is carried out on another 7 wrongly predicted samples. The overall uncertainty is reduced. Upon update, confusions between classes are still observed. The expert checks the edge distribution. For each partition, a bar chart displays the ratio of homogeneous edges and heterogeneous edges. 4 partitions have relatively high ratios of heterogeneous edges. The expert analyzes P1 first, as it has the highest ratio of heterogeneous edges. The detailed distribution shows that the cat and dog classes have the highest confusion. The expert selects the confused region and zooms in. A bar chart displays the ratio of homogeneous edges for each class and heterogeneous edges. The ratio of the heterogeneous edges is higher than that of the red class. Many samples have high uncertainty and have lower ranked neighbors in wrong classes. To reduce the number of heterogeneous edges in this region, the expert decreases K. Upon update, heterogeneous edges and uncertain samples are both reduced. For the remaining uncertain samples, their individual propagation paths are checked and refined. In the same way, the confusions of the remaining partitions are analyzed. After this step, the confusions, heterogeneous edges, and overall uncertainty are reduced. However, the ratio of heterogeneous edges in P1 is still noticeably higher than others. As there are few confusions, the expert speculates that the high ratio of heterogeneous edges may be caused by the small number of homogeneous edges. The smaller number of cat samples confirms this speculation. The expert then added 500 more unlabeled samples that are more similar to the selected cat samples. Upon update, the ratio of heterogeneous edges and the overall uncertainty are reduced. As the added nodes cause some local changes in the graph structure, a second round of modification is carried out. This table shows the improvement of model performance on test data after each step. Another case study is conducted on an OCT dataset.